Hello and welcome to another episode of Labs Talk.
Welcome, everybody. Hi, Markus. Hi, Andreas.
Hey, Markus. Hey, Sven.
Happy we're talking again about AI today, right?
Happy to see all of you and happy to talk about AI.
Yeah.
And Markus, I'll get to you in a second. We spoke about something very specific in AI quite a while back. We've been rather lazy.
Been a long time back, actually, right? So you mentioned 6 weeks or so.
Something.
I think we talked about security in AI with Linus, right? In the last episode. That was quite exciting, actually.
Which was super exciting. Linus Neumann really had some exciting insights. And we stay on the topic of AI today. It's going to be quite a different topic.
Yeah.
It's not going to be about agentic AI, but something that really has a huge worth in the market, to my understanding. You told us about the market share and everything. We're going to get to that. But Markus, just start with an introduction about yourself.
Hi, I'm glad to be here. Thanks for the invitation today. I'm directing research and development at Senswork. Senswork is a company specializing in optical measuring and testing. That's, for the most part, visual analysis, hence our industry name, machine vision.
Mm-hmm. Okay.
Markus, we met you at the DLD Future Hub conference, which was all under the topic of generative AI, LLMs, and we understand that thing that you're doing, that's something entirely different, although it's still machine learning and AI. Maybe explain to us how that's different and what it's other than LLMs and the big hype.
I just wanted to say, we're not talking about generative AI here.
No,
what's wrong?
What's wrong?
How did that happen? So explain what you're doing, actually, and why is it not LLM based, basically?
So, since ChatGPT grew large, there's a huge buzz around generative AI, LLMs, and in general, AI is nowadays perceived with these kind of applications. In fact, the topic of AI is much larger. So if you think back about 10 years, people talked a lot about AI models that were able to qualify things in images, for example, or in complex soundscapes. So in general, these kind of applications are subsumized under the term discriminative AI.
And that's basically discriminative AI versus generative AI. So discriminative kind of meaning we detect things and
we classify things, we differentiate things, we qualify things, which means it's usable in industry use cases, and it's got a high precision if trained with the right data.
And industry use cases in a sense of that, so we're talking about, let's say, big factories, for example, right? Where, let's say, there needs to be some quality control and it needs to be probably very quick and efficient, for example. So that's the typical use case where some of your software is used then, or?
Our software, Senswork, yes. So we're doing machine vision, so exclusively optical analysis. What we're doing in the AI field is going under the term vision AI. And we're working in industrial production for the most part. So it's like you say, things are produced, parts are produced, subcomponents, and in a modern factory, you always try to get 100% quality, which means you're looking at every part that passes by in every plant, at least 10 to 15 times.
And it needs to be, I'm tempted to say 100% correct, and which is a hard thing to achieve with generative AI, for example, right? Because there are hallucinations and things like that, and I think there's a lot of progress made when it comes to generating some answers that are more or less correct, right? But it's still hard. But I think, if I understand this correctly, the field you're in, when it comes to vision AI, it is probably nearly 100%.
Yeah, it has to be. because
has to be,
I mean,
the result. Yeah,
there is a way of gaining more flexibility when using LLMs, for example.
Yeah,
or generally generative AI. But if you, for example, are in a self-driving car, you need those you need those guardrails, and a 5% error rate doesn't bring you anywhere. So and even if you have only 0.1%, that's still one defect in 1,000.
Yeah,
which is
really interesting.
Which is a pretty high number in automotive production.
Scary number.
Maybe let's also step a meter back also, right? And discuss quickly why we're having this show, right? Because I mean, we had so many episodes now about LLMs, right, and agents, and the hype around it and the trend, of course, right? That I believe we thought very often we forget there's this, I would say, traditional part of AI, right? That has great importance for the industry, for example, right? When it comes to industrial processes, and that's exactly what you're working in, and that's why we wanted also to highlight this part of AI, which I guess we're calling it vision AI or discriminative AI, and it's not about having an agent in this case that is self-planning and then basically more or less making all kind of calls to tools and stuff like that, but it's really about very efficient industrial automation, basically, right? And detection. It's engineering, yeah.
In the end, it's engineering.
Yeah.
And if you look at the current buzz around AI, the question that should be posed is not whether you or we can keep up with AI and build the next large language model, but if we realize that we have a huge part of economically valuable AI application already here for a decade.
And to stick with that part, when we had this prep call for the show, we were talking about the market perception already to pick up that economic viability that you just talked about. That is not something that you're building, that you're bringing out on the roadmap, but that exists today. You talked about the market perception of these industrial applications, and also at the DLD conference, you talked about how this is in contrast to this hype right now. It's you doing real business with that, and it has some value today already, right?
Yeah, of course. It's nothing new. It's just something invisible. That's that's just, well, let's put it like that. Somebody who is manufacturing something in industry doesn't tell his competitor his newest technological edge. So for this reason, machine vision is an engineering an engineering field that exists for 40 years now. We're actively deploying machine vision and vision AI systems for more than 10 years. These systems are running, and just to give you a number, only the German proponents of machine vision have a turnover of about 2.8 billion a year. So this is the number of last year, but it's been roughly the same the years before. So this is not just an idea that I'm coming along with. It's something that's probably generating more revenue than most other AI applications out there.
Okay, that's amazing. That's quite a decent number, proper Mittelstand, I suppose.
Yeah, well, that's it.
So let's talk maybe a bit about how discriminative AI works then, basically, right? I think there are quite some differences when it comes to generative AI, right? So we discussed in pre-chat, for example, that you basically, and one of the big differences that I see is that you need training data, for example, right? There's a training phase, and then there's a new model, for example, whereas in generative AI, typically you start with an existing model and you just prompt something, right? And you hope it's able to classify, for example, or based on your prompting, for example. So so how does this work, basically, from the idea to detect something to a ready to use system? What is the process and the steps involved here?
So well, any engineering company doing what we do is just cooking with water. So nearly nobody is inventing the wheel. from scratch. It's like you need a certain kind of model, be it YOLO, UNet. Old models are often very helpful, to be honest. If you need safe applications, and model is the one part.
Yeah.
Another part is the data, and third part is the process that leads you from your initial idea or problem to working application. The process itself is often captured in something that's called ML ops, machine learning operations, which is a structured concept from getting from A to Z.
We take a life picture, I guess. Okay.
And you need to master all three. Whereas I would say that for the model part, we don't invest an enormous amount of time. We're tweaking the inputs and outputs layers, but we're using off-the-shelf models.
So you have minimal modification to the models. It's not like you have to spend weeks on training a new model or something. Like that, right?
Training is something different. So this model is really pristine. It's not pre-trained by anything.
But that training, as you said, goes into the final layers basically. That then still needs some time, basically, right? So
the data in our case is always coming from our customers, and they're not interested in giving this training data out because it contains images of the product from different stages in the production process. So it's intellectual property.
Yeah,
and if we're having good experience with a certain type of model, and we know, for example, scratches, cracks, or something like that is very well determined by this model, we start training with exclusively with the customer's data. So you can do all this in your lab setting with your Python notebook whatsoever.
Yeah.
But this won't bring you to a working industrial process in an engine that runs 24/7. So in the end, this ML ops approach that guides you through the process, not just on a pen and paper strategy, but create it as a piece of software. In the end, is the most valuable asset and all that. That's what we've been doing the last 5 years in implementing our vision AI platform Neuralize, which really is, in the meantime, also by putting some time into user experience and ergonomics on a level where somebody who hasn't done anything before like that, but is a domain expert for let's say, costing. Whatever.
Only to let me recap what I understood now, that you're basically producing a software, you're enabling a process to improve industrial processes, to enable classification for QA type of processes, or generally improve quality. And you're leveraging off-the-shelf AI models. That sounds a little bit like AI models for what you're doing, a bit of commodity already, and you enable that to embed, or you embed that into a process, and you enable to leverage that model to improve the process later on. Is that a fair summary?
Well, it's rather like we're providing a whole platform which just lets you implement your neural network analysis of a certain, let's say, optical feature, and put that into your production machine on a low threshold.
And when you talk about production machines now, so what kind of infrastructure are we talking about? So are these basically, I don't know, Windows laptops, Raspberry Pis, complex whatever processing
I
units?
understand it's like literal production machine.
I mean, what's it running on in the end, really? In this, especially in this industrial setting, I guess, right? You probably don't have a MacBook standing around, right?
No. Well, in industry, you have this classical differentiation of machine engineering and the electrical engineering, computer science part typically. And the machine engineers are building the whole production part. And in the end, we integrate. It's also what we're calling ourselves an integrator, a machine vision integrator. We integrate industrial camera systems, which are not the good old Canon camera, but very particular industrial sensors with selected illumination, maybe with filters. So we build the whole optical setup, which we call acquisition engineering, which is a huge asset on itself, because if you put garbage in an AI system, you will get garbage out. So the quality of the input data is one of the most important things. And we often work on workstations, what you would call now on-premise. But it never changed in the last 30 years in our business because the owners don't want their data to go out, and on the other hand, with the speed in which we have to transport the image data because of resolution,
you would not be able to run it into the cloud, right?
Delta. You have such high transmission rates that the cable specification doesn't allow lengths beyond 5 meters, for example. So you need to put the computing assets.
And I mean, you said that at the very beginning, right? So when you talked about, let's say, some driving assistance system or so in a car or so, right? You wouldn't want that to go out into the cloud, come back with a response, and then maybe it's too late and you already hit the car in front of you or something like that. So this is something, I guess, that we don't need to argue, right? There are a lot of applications of AI that should run locally as fast as possible, and they should run nearly perfect, I believe, right? Because if it's, I mean, if there's a little error. So I think maybe that's a good time to compare these LLM-based systems now to discriminative AI, I believe, a little bit. So in our pre-chat, we started this matrix here, right, with some kind of, here we said pros and cons, right? But maybe it's more like different, all different areas, basically, right? So I think if I understand it correctly, ML-based classification, it's running on-premise, it's very fast, it's highly accurate, right? And compared to that, I guess it needs some training time, right? So it needs time to train. It is maybe not as scalable, and it's maybe also not as user-friendly because you need integrators like you, for example, right? To create such a system.
Yeah,
it's also a totally different use case, though.
Yeah, so that's the point. For this reason, just on a side note, it totally makes no sense at all that in the AI Act, those two ways of using AI are put into a single legislation. And this is something that really prevents us from getting along in industry right now. But getting back to your question.
But let's talk about that next, actually. I think it's a good topic. Let's plug that for a second.
That as a talking point.
Let's go to the pros and cons quickly. Did I correctly more or less summarize these?
It's a bit difficult to actually compare it. But I mean, what we're doing is highly individual. It doesn't scale. It's not a winner takes it all scenario, which has to scale to billions of users to be monetizable. It's rather because of the product value that we retain by being able to constantly monitor it, and by the output that these producers of whatever objects are able to reach, and the cost they save, of course, by not calling stuff back or
I would also believe that, for example, when I look at some of the agentic solutions that I've seen out there, it is sometimes a bit hard to measure the real output and how successful something can be, for example, right? Totally. But here, I believe, right, we probably do some due diligence, and then you're able to detect, faulty materials that are passing by on a band or something like that, and that has probably some very clear
and
benefits, and it can also be put in numbers, right?
A KPI.
Yeah,
next
it has
to
a KPI.
Where you have good parts versus bad parts, and you can have a quota between those.
Funny thing is that's all been there even before AI was applicable because of let's say GPU performance that was rising so quickly. So everything we do is just, let's say, a successor technology to the conventional rule-based analysis that's been done 30 years before AI was really in place. In this industry. So it's all the processes on how to handle an optical quality inspection systems are perfectly clear. Also in our customers' companies. It's just another method of analyzing the images in the end.
Yeah. Got it.
Got it. We spoke about the misunderstanding before, like in particular for the use case, but I don't think that's the only misunderstanding we spoke about in preparing this. So the other thing you called the academic misunderstanding and the assumption that a model can do everything by itself. Now you already spoke about how you train, you take a model off the shelf and you do adapt it to a use case. Right. Tell us a little bit more about that, maybe.
So, about how to use
off-the-shelf models, or how we're using scalable and
how we're making it work.
Still necessary. How that assumption is wrong that the model itself can do it already.
Yeah, well, you either have pre-trained models or void vanilla model, which are for the most part just freely available because people developing them are publishing them at GitHub, for example.
Yeah.
Then there are companies, or so third-party companies or companies that emerged out of some of the founder guys that do pre-training and supply well-trained models.
Yeah.
That you for which you're paying license fees afterwards. But you never know what's in there. And
okay.
well,
that's not different to an LLM, I would say, right? Because if I'm making a request to ChatGPT, I also don't know what it was really trained on.
And that's still under discussion. That's a topic for a different episode.
Yeah. But okay, so there are these companies that have proprietary models, and you don't know what's.
So the models itself are not proprietary, but the pre-training, so the data is kind of proprietary because right now with the new EU legislation, you need to have the right to use those images. So, which makes it really difficult to scrape anything out of the internet and say, okay, these are all rabbits, because now you would have to take all of those rabbit images by yourself, buy them from somebody, which is quite a huge task if you think your model should contain every visual object the world contains.
Yeah.
So you can imagine it doesn't make sense. For this reason, we try to convince our customers, in part, that so-called domain models make sense and help themselves if they in turn give us their or let us use their data. For example, if we have, let's call it a filiform defect detection model where we can detect scratches in die-cast parts, where we can detect cracks in streets, where we can detect hairs on your cake. So everything that's that has a certain shape, and then if done well, be detected with such a domain model, which is still small compared to
the LLM,
a large model, which but nevertheless, it's very useful for industrial use cases. So it's something we're trying to do. We're trying to build, but you really need high value data. You can't just run around with your camera and take photos, because that doesn't work. You need thousands of images. So you need to have a partner who's really coming from production.
So in other words, it's a very a model trained to do a very specific task and do that very well. And in turn, it would be able to apply. You would be able to apply that to a use case that's easy to scale up. That would make it a very, or that has the potential to be a good investment case after all.
Yeah, well, I mean, in the end, our customers are not producing goods because they want to deploy an AI model. It's the other way around. So the investment is producing something and selling it in a good quality.
And AI is just a helper here.
Yeah.
Of course. I mean, AI should just be a helper, right? I mean, you don't do it for AI. Also not in the agentic.
Here we sometimes talk about it the other way around. Which
that's often the case. So there's a hammer.
Hey, can I do something with AI? Yeah, but why? That doesn't matter.
Let's search a nail that we can hit with this hammer.
Got it. Yeah. Okay.
Oh, and we have a huge hammer.
Yeah.
Right. Cool. So did we already discuss should we talk more about the AI Act quickly? Actually, so
let's come to the end. You mentioned the AI Act and how that doesn't treat those use cases you talked about, right? Maybe we can come back to that for a minute.
Yeah, that's our impression. I mean, the politics regulatory part revolving around the AI Act has pretty much missed to talk to real industrial users, so both customers and companies like us who really create these kind of solutions, which leads to the funny situation that our use cases, so creating, let's say, 8 to 10 AI-based systems from really different parts of the spectrum, from food production to semiconductor to med tech, within a single month.
Yeah.
And we have to qualify all this. There's no way to do it. So there is no. It's not been thought through as a process that there could be somebody who's doing this, even though in industry it's pretty clear
that this is needed.
That this is.
So what would happen if the AI Act, like it is right now, comes basically then, or what does it stop you from doing right now, actually, the AI Act? Or is there, would you like to make changes, and if yes, which changes?
I mean, I'm very happy that there is this kind of regulation, because you wouldn't want to put your hands in some engine cabinet without this proper inspected by somebody before. Same thing for AI, in my point of view, but we need some differentiation between applications that use discriminative AI and others that use LLMs and generative AI. And what's probably most important, that the legislator talk to those companies who are really having the experience in the application of AI, and not with startups only, because that's the whole reason, from my perspective, why this went so wrong.
But just to take this a step further, do you feel like that's going to happen sometime soon? And to take this even one step further beyond that, how's the future going to look like in that whole field? What's coming next? What do we have to expect when we sit here in a year from now? What do we have to talk about?
So in the EU, there's a so-called omnibus. What's for fun?
Procedure.
Thank you. That allows to bring things forward the quick way. And just today, somebody from the VDMA asked me to write up what I would consider a really hindrance in what we need to do in this respect. And I hope this really gets us a step further. If not, it will create a lot of work on manufacturers like us, which are really building those systems in a vertical way. We're not just producing software; we build a whole special machine engineering and so on. So we need to do this to do this work, and if we need to do it on a large scale for each machine, or for each single machine, we need another person in our company who's just doing AI Act, which really makes no sense because we already have people who are doing.
And that's because all the regulative overhead, and basically, if it stays like it is, basically, then it just means a lot of overhead for you. Basically, that's what it means.
Yeah, and so there are well-known procedures that are already in place that we have to adhere to, like the Maschinenrichtlinie, or the EVA-Ordnung.
Guidelines for machines, stuff like that. Yeah,
everything we push out. Yeah, our warehouse has to be considered along those guidelines. And if you would take the AI Act just as those guidelines have been put into place, that would already be a huge benefit, and it's all there. So the VDMA and the VDI is here. They have.
So maybe you should explain that, right? So VDMA is Verband Deutscher Mittelständischer
Maschinen- und Anlagenbauer.
Maschinenanlagenbau. So that's basically the organization of the German machinery builders, more or less. And VDA is the Verband Deutscher
Industrieunternehmen
of the German industry, right?
So and the thing is, things are in place. There is experience with that. Yeah, and the legislators could just talk to those organizations.
But instead, they're now focusing only on the LLM based AI right now because it's so hyped, basically, right? And that's what is
that's
big.
That's back to where we came from, how we opened this episode. But still, I take there's opportunity for Europe as a continent, and we're at the right time. You would agree to that, right? That we can do something right as a continent here.
I think so. So it's already there. It's rather
we just need to put it into proper regulation.
Recognize that we are leading here. So it's not something made out of thin air. You can prove it. There are numbers, and there are industry players doing that already for a long time. So there's even the VDMA working group Machine Vision, which has, I think, 140 large companies.
Maybe we can create some recognition with this episode, I'd say.
Yeah.
Thank you for your perspective.
Perfect. We're at the end of our little script here, right? So of our mural board, of our post-it collection here, right? So,
Markus, thank you for sharing your insight.
Markus. Thanks for having me.
See you soon.
Perfect. Thanks everybody for watching. Bye-bye.
Bye.